Dear students, welcome to the video Infinite Geometric series. In this part of the chapter, we are going to learn how to find the sum of an infinite number of terms in a geometric series actually. As you already know, sum of the n terms of a geometric series is a plus ar plus ar squared till ar to the power of n minus 1. Now, we are going to see what happens if n tends to infinity. Means that you have an infinite number of terms to add. See if
it's 2 hours.
The common ratio, which is r, is a number greater than 1. We know that when you have a number greater than 1, like 1.5, 1.2, 2, 3, whatsoever, greater than 1, any number. When the power increases, so these terms will be increasing, and if you have a power tending to infinity, then these terms will tend to infinity. So then the sum will be infinity as well. So the sum will tend to infinity. Likewise, if you have a number less than negative 1, like negative 1.5, negative 2, a number less than negative 1, when you have power tending to infinity, then again it will tend to infinity, either positive or negative. Now, but our focus here, actually our aim is here to find the sum of n terms when the common ratio is a number between 1 and negative 1, or you could say absolute value of r is less than 1. They are equivalent, means that r is taking a value between 1 and negative 1. Now, we already know Sn is a 1 minus r to the power of n over 1 minus r. When you have a number between 1 and negative 1, like half, negative half, 1/3, 1/5, when the power increases, the whole fraction will reduce. When n tends to infinity, then the fraction will tend to 0. Consider, for example, a number like half. Half to the power of 2 will be 1 over 4. To the power of 3, 1 over 8. To the power of 4, 1 over 16. To the power of 5, 1 over 32. To the power of, for example, 10, 1 over 1024. As you notice here, when power increases, the fraction will be decreasing. So it tends to almost 0. So you can easily cancel out r to the power of n because it tends to 0. So sum to infinity will be equal to, here you have just 1 left, so 1 over 1 minus r, just in case that r is a number between 1 and negative 1, then you can say that this series is actually convergent to this number, otherwise it will tend to infinity. Now look at the examples. Example 1, the first 4 terms of a geometric progression are 5, 4, 3.2 and 2.56. First part, find the common ratio, and part B, find the sum to infinity. In order to do the first part, common ratio, we know that the ratio between any two consecutive terms will be giving you the common ratio. R is 4 over 5. Now, as r is between 1 and negative 1, 4 over 5 is a number between 1 and negative 1. So it is convergent, and it has sum to infinity obtained by the formula a over 1 minus r. So a is 5, over 1 minus 4 over 5, which will be 5 over 1/5, giving you an answer of 25. So sum to infinity is convergent to 25. Example 2, a geometric progression has a common ratio of negative 2/3 and the sum of the first three terms is 63. First part, find the first term. Part B, find the sum to infinity. To do the first part, as it's given in the question, R is negative 2 over 3 and S3 is 63. Now 63, which is S3, is A 1 minus R, which is negative 2/3 to the power of 3 over 1 minus 2/3. After simplifying and doing cross multiplication, A will be 81. Now to do the second part, find sum to infinity, as the common ratio, which is negative 2/3, is between 1 and negative 1, so it is convergent. So you can implement S to infinity, which is A over 1 minus R. A is 81 over 1 minus negative 2/3, which simplifies to 48 and 3 over 5 as the final answer.